In this lecture, presented by www.free-academy.com, we're going to be covering problems 17 and 18 of the text, which will be practicing our product rule. It's important that we get familiar with the product rule because it's very important to doing derivatives. So, without wasting any time, let's start and do problem 17. Now, the procedure for doing the product rule is generally always the same. The derivative, let's not write that here. The derivative of f and times g is equal to f prime g plus g prime f. This is our product rule, and our procedure, we're always going to need to pick something to be f and something to be g out of our function. This is completely arbitrary. We can choose this however we want, but in any case where we have two things that are multiplying each other, we assign one to be g, one to be f, and then we apply our product rule. And as long as we're self-consistent, we're not going to have any problems. Now, whenever you have something with two parentheses multiplied by each other, it's very common to assign the one set to be f and one set to be g. This is most convenient. But in a situation where you have like x times sine of x, we know how to take the derivative of this. We will learn how to take the derivative of this. So we would call f is equal to x and g is equal to sine of x. And in fact, without using the product rule, there's really no other way to do this derivative. But we're still staying in the realm of convenience here because we can distribute out all of these terms here to find the derivative. It's just that it's going to take a long time, so we don't want to do it that way. So since we've picked f to be equal to x to the third plus 7x squared minus 8, and g is equal to 2x to the minus third plus x to the minus fourth. To do our product rule, we're still going to need f prime and g prime. The derivative of f is very easy. It's just going to be using the power rule that we've learned in previous lectures. It'll be equal to 3x squared plus 14x. Now let me just rewrite that there. Make sure you guys can read it. And remember, with our constant rule, whenever you take the derivative of a constant, it's equal to 0. G prime is going to be negative 6x to the negative fourth minus 4x to the negative third. I encourage you guys to go back and check out the power rule lectures if any of those steps are confusing to you. Now that we have f prime, g, and g prime, we have all the components necessary to find our derivative. So our derivative of f of x is going to be equal to f prime, which is 3x squared plus 14x times g, which is 2x to the negative third plus x to the negative fourth. So it'll be plus g prime, which is minus 6x to the negative fourth minus 4x to the negative third multiplied by f 3x squared plus 14x. And that's our derivative. Now, I spent a lot of time talking before we actually got into solving this problem. Solving it's very easy. You take your function, you split it in half, calling 1/2 f, 1/2 g. You find the derivatives of f and g, and then you just simply plug everything into our formula. Once you do those steps, you have the derivative. It's very quick, it's very convenient, it's definitely much faster than distributing out all the terms and using the power rule. And in the example I showed with x and sine of x, sometimes the product rule is the only way to find the derivative. Now let me clear some room here, and we'll go on and we'll do problem 18. It's going to be the same process. We're going to call half of it f and the other part g. And notice the reason that I'm assigning the first parenthesis to be f and the second parenthesis g is that these two are multiplied by each other. It doesn't make any sense in this, say, for 2x, x to the minus third plus x to the minus fourth, to call this f and this g to apply the product rule. It doesn't work because f and g must be multiplied by each other. Now, although I should say in this example here, you can very well assign one part to be f and g. You just can't use the product rule to find the derivative. So let me rewrite the product rule. The derivative with respect to x of f times g is equal to f prime g plus g prime f. F is equal to 1 over x plus 1 over x squared, and g is equal to 3x to the third plus 27. We'll need f prime and we'll need g prime. To find f prime, we want to use the same trick we used in our power rule lecture. We'll rewrite f as 1 over x is equal to x to the minus 1. 1 over x squared is equal to x to the minus 2. Now we can apply our power rule to get minus x to the negative 2 minus 2x to the negative 3, which are very similar derivatives that we did in the first example. To find our g prime, this is a little bit more straightforward. It's 9x squared, and the 27 goes to 0 when we do the derivative. Now that we have f prime, g, and g prime, just a matter of plugging everything into our formula. So the derivative of f of x is equal to minus x to the negative second minus 2x to the negative third times 3x to the third plus 27 plus g prime, which is 9x squared, times f of x, which is x to the minus 1 plus x to the negative 2. This is f prime, this is g prime, and this is f. Just plug everything in and you get the derivative. We got a couple more practice problems that we're going to do with this product rule, and then we'll go on to trig derivatives after our quotient rule, of course. And then once we have trig derivatives, we're going to come back and we're going to practice the product rule some more, knowing those. So check it out.